Hello students, let us discuss about higher order derivative test. When we go for higher order derivative test, suppose when you are finding maxima minima of a function using the first derivative test, if you are able to find, it's okay. But sometimes we cannot find using the first derivative test maxima or minima, then we go for the second derivative test. And one more thing is, if you want to know at a critical point the function is became maxima or the function is minima, to know that we can use the second derivative test. Let us see what is second derivative test says. So second derivative test says that f of x is a function. If suppose f of x is a function at a point x is equal to c, f double dash of c is greater than 0, then we can say the point of minima. F double dash of c is less than 0, then we can say the point of maxima. If f double dash of c equal to 0, then the second derivative test fails. What is this? I will discuss. Okay, you may get doubt what all these things. F double dash of c greater than 0 is what is this? So let us discuss that one. Okay, so you know already I have explained in the previous class. So if you take here, you know this is the minimum, right? At this point, if this point is a, dy by dx is here is 0. dy by dx here is 0. And if you draw here, this is the slope. This slope is positive, right? This slope is positive because you can see this bend is positive. And you can find another slope. About this point I am taking two slopes. So here right side and left side, a plus h, a minus h, like that. So if you see here, the slope is positive. When you see is the slope here, if you see this angle here, the slope of this one is, you can see, more than 90 degrees. Tan 9 more than 90 degrees is negative. Tan more than 90 degrees is negative, correct? So tan less than 90 degrees is positive. So you can say if it is positive, the function is increasing. See, this graph is increasing. Okay, right? When it is negative, the graph is decreasing, coming down, right? So what is that? Dy by dx. If dy by dx is positive, we can say it is increasing, correct? Dy by dx, if it is negative, we can say that is decreasing function, correct? Now dy by dx is what? Rate of change. Change in function, correct? Changing function. What is d by dx of dy by dx? It is rate of change in slope. This is rate of change in slope. This is a change in slope, correct? Now let us discuss. You have a graph like this. This is the point we'll discuss. This is the point A, you think. This is the point B, you think. This is the point C, you think. If I draw a line, tangent, if I draw a tangent, this line you consider x1, this line you consider x2, this line you consider x3, correct? If dy by dx, this you can dA by dx, you can see dA by dx, at this point the slope is 0. dB by dx, at this point the slope is, you can see here, this is first quadrant, positive. dc by dx, you can see this one. Okay, its a bend is in second quadrant, so it is negative. So what is change in slope? Change in slope is nothing but, what is meaning of change in slope? Okay, change in slope is another measure change from right to left, measure of change from right to left. Okay, change in slope. So suppose if I want to find from here right to left, okay, right to left, if I want to find the change in slope, slope through the a line, slope through the point A minus change through the point B. So if you see at the point A, it is 0 slope. At a point B, the slope is what? The slope is something positive, something, this is positive. So I can say slope change is final minus initial, you can say, or you can say that is also final minus initial. So 0 minus something positive 0.5, I am getting totally negative. So at this point what I got is change in slope, I got negative. Means dy by dx of d by dx, I got negative. So you know this is called as A is point of maxima. So dy by dx, if it is, so what I